Welcome to the continuation of Chapter 3 of the first section of the Predictive Interaction Design course. Today we're going to be looking at mapping out the user journey before they make an interaction with the system. So previously, we've asked the question, before a state is formally requested in the current system or experience, does an event occur that coincides with a high chance of this state being requested? Now, the way to identify this event is to analyze the user journey leading up to the interaction and seeing if there's any certain action that they take that we can measure. But let's have a look at actually looking at that user journey. So here I've got something called the interaction map. And this is a blank canvas where we can write down all of the steps that the user takes before they make the interaction with the system. And we can have a look at all of the touch points and we can see what they do and then what the system also does. Now, as a continuation of the previous part of this chapter, we're going to be looking further at that TV example. Now, let's break down this map a little bit first for you. So at the bottom of the map, we've got time. So we go chronologically from left to right. And then we've got a row for the user on the upper section. So that's where we write down everything that the user does. And on the bottom row, we've got everything that the system does. And as we look through all of the interaction maps through this course, you'll get a better idea of how we can achieve those faster, more efficient or secure user experiences. So this is a blank interaction map, and this will be available in your course materials. And what you can do is you can print this out and you can write down from left to right on here. I personally use a tablet to do this, so I just write on the screen. But for the purposes of this course, we'll have a look at some filled in examples that I have actually written down beforehand. Now, if we look at the top, we've got a few other points. First, we've got the start of the user journey, and we call this the point of first environmental interaction. Now, this is the start of the user journey and is the earliest point at which we can practically measure that the user is going to have any indication of interacting with the system. Using any events or occurrences before this would probably not be practically possible to measure leading up to the interaction. Then we've got in purple a couple of prediction events. So these are the things that we measure to then enter intermediary state for our system. Then in red, we've got the point at which the user actually makes the interaction. And then at the end in blue, we've got the completion of the requested state. So this is the point at which the system has delivered the outcome of what the user has requested. And then in that kind of red box there, we've got the time taken between that interaction and the end of the requested state. Now, this is not to scale in terms of actual time, but this is to better help you visualize the process. This will be part of your course materials, and this is a blank interaction map. So best practice is to print this out and annotate, or if you've got a tablet handy, you can get an image of this up on your tablet and you can annotate over the top of it, which is what I'm going to do for this example. But for examples after this, I will save you from my terrible handwriting and we will look at pre-filled examples. Okay, so what I'm going to do here is I'm going to fill this in with the same example that we were using in the previous part of this chapter, which is the example of the user turning on the TV. So the challenge here is that the user goes and presses the power button on that TV. And with these modern television systems, it just takes forever to load up and for it to fire up. And then they just want to watch TV, right? And this thing's taking forever. So we want to make that experience faster for them. So let's look at all of these steps that the user takes leading up to the point at which they push the power button on that TV remote so that we can then deliver that faster interaction. So let's go with the start, which is the point of first environmental interaction. So this is the first point, again, at which it's practically possible to measure that the user wants to make an interaction. So, well, what we can do is we can write here that maybe the user enters the room that the TV resides in. So I'll just write here, user enters room TV resides in. So that's in the user section of the map. Now, if we look down at the system section of the map, well, the TV isn't doing anything. The TV is in standby. Now, what is the next thing that the user does that we could measure as a prediction for them wanting to interact with the TV? Well, they then go ahead and pick up the TV remote, right? So they then pick up TV remote. Then, after doing that, the user then usually points it at the TV. So user points remote at TV. Now, again, through all of this, the system is still in standby. And then the interaction itself, or the state request, is the user actually pressing the power button. So I'll write down here, user presses power button. And then it's only after this interaction is made that the TV then fires up all of its components. So I'll write this in the system section of the interaction map here, but after the user has interacted. So all components initialize and load, and then display and speakers turn on. Again, I will save you from my handwriting immediately after this slide. And then the end or the completion of the requested state in the blue there is that desired picture plus sound output is playing. Okay, oh, that's much better. So what we've done is we've filled in the interaction map here. So we've got our challenge at the top. The TV is slow to turn on, and we want to make this user experience faster. Then if we have a look, we've got the point of first environmental interaction. This is the earliest point at which it's practically possible to measure that the user wants to interact with the system. And that's when they enter the room the TV resides in. Again, at the bottom, the system is in standby. Then the user picks up the TV remote. Then they point it at the TV. Again, while this is happening, the system is still in standby. And then at the point the user presses the power button, so that's their interaction or state request, the user then has made this state request, and then all components must now initialize and load, including the perceptible and non-perceptible components. And then the user eventually gets picture and sound playing after some time. Now, let's look at this interaction map with predictive interaction design implemented. So now what you can see here is that, again, when the user enters the room the TV resides in, nothing happens. The system is still in standby. Then after event 2 here, where the user picks up the TV remote, a motion sensor has been integrated into the TV remote that detects activity and signals to the system that it should enter silent next state. So then while the user is picking up this TV remote and then pointing it at the TV, all of the non-perceptible components are initializing and activating in the TV without the user's knowledge. And because this is a power state, we call this light sleep, which is a form of silent next state. We'll be talking more about light sleep a little bit later in this section. Then, by the time the user has pushed the power button, the system has had some time to preload the state request that the user wants, which is to be watching, TV with picture and sound. Then at the point at which the user has pressed the power button, just the perceptible components need to activate, which is the screen or speakers, and then the TV just instantly turns on, and that ensures that magical user experience. And even if there isn't enough time for the components to initialize fully, at least the interaction and user experience is much faster. And we can see that red zone there, that point in between the state request or interaction and the completion of the requested state, compared to the first one, is smaller. And that's the goal of predictive interaction design here. We're reducing the time it takes. We're reducing that delay, that lag between the user's interaction and the completion or delivery of the state that they're requesting. So this really helps us visualize all of the things that the user does before they make that interaction. Now we can see here that we've got 3 things that happen that we could measure, right, before the user interacts. We've got event 1, which is that point of first environmental interaction, and that's when the user enters the room the TV resides in. Then the user picks up the TV remote, and then they point it at the TV. But why have we chosen event 2 here? Why have we chosen the point at which the user picks up the TV remote to trigger the system to initialize silent next state? Well, we're going to be having a look at that in the next part of this chapter, where we look at a further tool we can use to break down the events that we've written down here and choosing which one to trigger the system to enter its silent next state. So I'll see you in the next part.